In this video, we are going to look at graphs of the exponential function. You will find this on page 257 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. In this section, we shall take a look at the graphs of exponential functions. In the quadratic function, that is x to the power of 2, the variable x is the base of a power. This is different from the function y equals 2 to the power x. So in this case, the base is the variable. In this case, the base is a number, a constant, in which the variable x is the index. Now, x is the index, there 2 was the index. So it's almost like it's just swapped. The general form of the equation of an exponential function is given by y equals a to the power of x, where a is a positive integer and a cannot be equal to 1. Okay, because then it's not going to give you a curved graph, just a straight line. Okay, so exponential equations. So again, do the same. You just do substitution. And then you just plot your points and you draw your curve. Now, in this case, it was 2. And I want you to notice, and I want you to check the difference. So in this case, it was 2x. In this case, it was 3 to the power, no, not 2x, but 2 to the power x, 3 to the power x. So again, it's almost like this is shifting closer. If this number becomes bigger, it's shifting closer to the y-axis. Okay, so just check the difference. And again, we are going to look at an example, and then I'm going to give you can do your own example. So complete the table on a sheet of graph. Okay, so first just do substitutions, find P and Q. And then, okay, so I just do be careful for your exponents. You can use your calculator. Sometimes it's good to put brackets if you set a half, but this will work. The same there. And then use a sheet of graph paper using a scale of 2 to represent this on the x and 1 on the y. Draw the graph. Okay, so then you just go and just look here, and you're just going to plot all the points. Don't leave out a point. If they are giving you the table, you have to plot all the points. Okay, and then with your freehand, you just draw the curve. And then draw a suitable straight line and use it to solve the equation. Now, if you look at this is 2 to the power x, and this is just 3x. So this is the one equation. So the other equation, if I break, is y equals 3x. And this is the equation that you must. But remember, always make your table. I think 2 points will be enough. So 0, 0, 4, substitute, and you get 12. And you just draw your line. And that's that. Okay. I want you to stop the video, and I want you to do number 1. You can continue the video as soon as you are finished. Okay, and again, I'm going to do it like this. I'm going to do all the calculations on this page, and then on the next page, I will draw the graph. Use it to draw the graph. Okay, so let's start. So number A. This is y is equal to 3 to the power of x. So complete the table. So I must find p. And what is the value there? It's -1. So if I'm going to say y is equal to 3, and I'm going to say to the power -1. So it's actually just a third. And if I'm just using 2 decimal places, just like they did, just do what they did, then y is going to be 0,33. But then please end with this. P equals 0.33. And then the next one, Q. So use again your equation. And now put in the place. Sorry. To the power of 0. And the answer will be 1. So therefore, Q is equal to 1. Okay. And in number B, again, complete the table. Again, your formula, and what kind of formula is this? This was exponential, and this was a quadratic. And do you see that the a value in front of x squared is negative, so it's going to be a grumpy face. Okay, a negative person. So if I'm going to look, it's just r that they want, and what was r? R was 0. So y is equal to 3, put the 0 in brackets, put the 0. This is nice, so y is just going to be 3, so therefore r is equal to 3. Okay. Now, on a sheet of graph paper, using this 2 centimeter 0 point on the x and 2 to represent 1 on the y, draw the graphs. Okay. Now, in this case, I'm going to start with my graph paper, but first my tables. And I think it worked nicely when I was just writing the 2 here on top. I think I'm going to do the same. I'm just going to write the 1 here. Just want to take another color. And then I'm just going to say x. Okay, and then I'm going to, this was negative 1.5, and it was 0.19. And this was negative 1 and 0.33. And this was negative 0.5 and 0.58. And this was 0 and 1. And this was 0.5 and 1.73. And this was 1 and 3, and it was 1.5 and 5.20. Okay, I think I'm going to use another color for this one. This was negative 1.5 and 2.25. And this was negative 1 and 3, negative 0.5, negative 0, and 3.25. And this was 0 and 3, and this is 0.5 and 2.25. And this was 1 and 1 and 1.5 and negative 0.75. Okay. So in this case, it was, okay, that was my axis. Okay, so in this, if I must plan to see how I'm going to do this, so it's negative 1, so the line's going to be in the middle. But then if I look at my lowest point, where is there negative, say negative 1, and my highest point, it looks like 5, let's just see, 5.2. So I think if I'm drawing it here, it will work. So it can be in the middle, that will be correct. So let's see if this is the middle, 1, 2, 3, 4. Can be in the middle, and then I can just do it like this. I just want to see, because it's, just remember the scale. In this case, they say to you, I just want to read it again to you. They said just to represent 1 on the y-axis. And it must be up to, let's say, let's make it 6, because it's 5 point something. So 6, 5, 4, 3, 2, 2, 1, 0. Maybe we move it just a little bit up. And I do it here. I want to make it again bigger. So again, I'm just going to see if I can do it here. Okay, if it's going to fit. I'm first going to draw it here. It's just to -1, but let's just see if it fits, if it's here. So it's 1, 2, 3, 4, 5. I want to move it 1 down. I do want to see if I can move. Never tried this before. It's not working. So undo. And I'm just moving it 1 down. But by moving it 1 down, I just have to go this and also this. Okay, I think it's going to work now. So if I'm starting there, so this is now 0. And now let's just read the x-axis, 2 to 0.5. So this will be 0.5, then it's 1, then it's 1.5. I think it's going to be enough, but 2. And this is -0.5. And this is -1. -1.5, and up to there it's -2. Okay, and then the other axis, 2 centimeters to represent 1 unit. So this one is easy. Okay, let's just write it down. So this is going to be -1. 2, no, 1 unit. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay, and then where is that? Okay, now use your, okay, so plot, both of these graphs must now be plot. So let's make it smaller and start with that plotting. Let's start with the red one. This is the exponential one, and the equation of this one was y equals 3 to the power of x. Okay, so it's -1.5, and okay, it's very important for me that you understand this scale. Although the scale, no, I think the scale is all right. As soon as I read down, I'll show you the scale. So it's -1.5 and 0. It's almost 2, but it's 0.19. So this is 0.1, 0.2. So 19, so will be about there. Okay. Then this is -1 and 0.33. So 0.2. Okay, 0.1, 0.2, 0.3, 0.33, no, it's a bit too low. 33, it's not in the middle, but almost in the middle. Okay, it seems to me dots work better now with this pen. Okay. I just want to do it again, it's too low. Okay, and then -0.5, 0.5, so it's 5, 8. So it's 0.5, 0.6, but it's below that. Okay, and then it's 0 and 1, and then it's 0.5 and 3. 1, 2, 3, 4, 5, 0.5, and yeah, let's see. No, that's incorrect. It's 1 and 3. Okay, this one, I skipped that. That was 0.5, that's correct. And it's 1.7. Oh, 0.5 and 1.5673, and then 1 and 3, doesn't matter, 1 and 3, and then 1.5 and 5 point, what was it, 5.2, 1.5 and 5, there's 5 and 0.1, 2 there. Okay, I think just to make it easier, I'm going to already draw this graph. Maybe from this side it's easier. So right until there and then. Okay, you're supposed not to pick it up and do it in one smooth curve, but sometimes I would just pick up there at the points, then it's not noticeable, but try to do it without picking up. Okay, so then this will be y is equal 3 to the power of x. And then the green one, let's start with the green one. And what was the green one? We can just write down quickly the equation of the green one. It was y equals 3 minus x squared. So it's negative 1.5 and 2.25. 2, there is 2.125. It's there, notice. Okay, 2 point, so it's 0.1225. Okay, it's 3. And then it's negative 1 and 3. And then it's negative 0.5 and 3.25, 3.125. It's again approximately there. And then it's 0 and 3. And then it's 0.5 and 2.25, 2.125. Let's just see, 0.5 and 2. And then it's 1 and 1. And it's 1.5 and negative 0. Negative, let's just go. Negative 0.75. So I have to move this up a little bit. So let's just see. 1.5 and negative 0.75. 0. Okay, so it works, there is 5, 6, 7, 5. Oh, it's a bit. Okay, and if I draw that line, okay, and this equation will be y is equal to, okay, let's just write it down, 3 minus x squared. Y is equal to 3 minus x squared. Okay, and then now I can start. That is what they were asking. And then use your graph to solve the following equations. Okay, I'm going to start here. So the first one they say, and they're referring to the parabol type of one. So it's actually the parabol. And again, check, in the place of y, they put a 0. And I already said to you, all this is called the x-axis. the equation is y is equal to 0. So where does it cut the x-axis? 0.1? Okay, now you have to check this scale. Now how I teach people or students to do this scale is to do it, take 0.5 and then just divide, how many blocks are there? 10. And if you do that, you will get 0.05. That means you must count in multiples of 0.05. So it's 0.05, 0.1, 0.15, you follow? Okay, so we are here now. So it's 1, 1.05, 1.1. So it's actually just counting 2 blocks and then it's 1, 0.1. So it's 1.1, 1.2, do you see? 1.3, it looks like 1.3 to me, okay. So if I look at this one, it's going to be x is 1.3, because then one block is counting, so every 2 blocks is counting 0.1, and that's where I get 1.3. 1.1, 1.2, 1.3. Okay, the next one, what is the next one? And now, check what curve they are referring to. So I'm going to write it in green because they are referring to what curve? They say 3 to the power x, and that is equal to 4. So again, actually they say y is 4. Now, where is the line y equals 4? It's here. I'm going to even draw, okay, I don't want to definitely not without a ruler. It's there. And where it cuts there, you're just going to go straight down. And you're going to read it down there. And it's going to be, okay, remember it's counting 2 units, so it's 1.1, 1.2, it looks like 1.25. So x equals 1.25. Okay, and then number C, oh, it was actually not C. It's, okay, can I just correct this number? I don't like that the numbers is not correct. This was number D, and this was the first one, and this was the second one, okay, and now the last one is the third one. And now I'm just going to, oh, and what am I doing now? Check. I say 3 to the power x equals 3 minus x squared. So this is my exponential, this is my parable, and I'm asking you, where are they equal? They are equal where they intersect. They intersect there. And if they intersect there, I must just write. And if they do it like this, they don't ask you the coordinate point. They just ask the value of x. So it's going to be 0.6. So therefore, x is equal to 0.6. So if you solve this with algebra, you will get 0.6. But remember, it's a graph, so it can be a little bit out. That's why it's an estimation from your graph. But it's where the 2 graphs intersect. And that's how you do an exponential graph combined with a quadratic graph or a parabola.